Right, so let's go on and work out the units of work, given that it is defined as the product of displacement and the component of force parallel to the displacement. So let me write the definition down. Mathematically, W is F, and the component of the force that is parallel to the displacement means that you multiply this force by cosine theta. Theta is the angle between the force and the displacement vector. So the angle between this force and the displacement vector is angle theta, and then when you multiply this force by cosine of this angle, then you get the component of this force that is parallel to the displacement. Okay, so the units the units, let me just erase that there. The units of work are, well, note that cosine theta is just a number, so it's dimensionless. It does not have any units. So the only units we have here will be the units for force, which is newtons, times the units of displacement, well, that is meters. But we must write this in terms of base units. So meters is already a base unit, and then we just have to write newtons in terms of base units. Let's recall that 1 newton is 1 kilogram. Let me just kilograms. Okay, let me just erase that. Okay, and then we'll go on again and say equal to, okay, that's a rainbow nation. That's equal to kilograms meters per square second. That is that is F is MA, so newtons is kilograms meters per square second, and then I multiply that by what? By meters. And then what do I get? I get kilograms square meters per square second. So that will be the units of work in terms of what? Base units. And of course, note that the definition, okay, note that the definition of Newton times meter is joule. Note that 1 joule, okay, 1 joule is equal to Newton times meter, okay, which is equal to kilograms square meters per square second. All right, and then let's go to the second one. We will do the same thing. Power, we define power as the rate of change of what? Sorry, the rate at which work is done. So that's power is equal to the rate at which work is done. So that's work done per unit time. So therefore, units of power. So what are the units of power? Well, that's just 1 joule over 1 second. Okay, but in terms of base units, that is equal to, well, we've determined that 1 joule is actually what is 1 joule? 1 joule is Newton times meter, which is kilogram square meter per square second. So then we have kilograms meter squared a square second over second, which is equal to kilograms square meter seconds to the power 3. All right, that is that one there. So also note that the definition of 1 watt is 1 joule per watt per second. So therefore 1 watt is equal to 1 kilograms square meter seconds to the power minus 3. So that will be the units of power in terms of base units. It is kilograms square meter times seconds to the minus 3. Okay, right.